So hi, thank you for having me. My title for my presentation is kind of long, so I'm gonna let you guys read it while I introduce myself. My name is Sarah Maria dos Santos. The co-authors are my lab mates Reese Levea, also Nia Renee, who was a Sussard Fellow and is now working for NOAA, Stephen Morton, my NOAA advisor, and Jennifer Charrier, my research advisor. I am an undergraduate at Brooklyn College-CUNY, and I am also a NOAA Sussard Fellow. So here's my presentation outline. I'm going to start with an overall introduction, go into the background, what's the problem or solution that we're looking into, the methods applied, some preliminary results from the study, and the significance. Okay, so to start off, as in many cities, New York City has lead pipes for plumbing. A lot of the lead plumbing comes from pre-World War II buildings, so it's kind of difficult to remove these. So what New York City Department of Environmental Protection has been doing since 1992 is that they add 1 milligram per liter of orthophosphate into New York City's drinking water supplies. Also, the feed water for NYC's urban lakes is the municipal tap water. So unfortunately, throughout the past 2 decades, there's an unintentional accumulation of dissolved phosphate. So this results, the phosphate is a nutrient source for various toxin producing harmful algal blooms. So harmful algal blooms is just an excessive growth of these plant-like microorganisms. And there's a chronic summer microcystis blooms and NYC urban lakes. So there's a lot of urban lakes in NYC, but probably the most common one to us is the lakes at Central Park. So here's a picture of a harmful algal bloom event in Central Park. You can see it's like a slimy green color. Central Park is in Manhattan. Prospect Park is located in Brooklyn, which is the location of our study site. So why does this matter? Why do we care? Microcystis blooms produce toxins, and toxins can be harmful, even deadly. Also, the public's perception, the public's concerned, it doesn't look healthy. So this disrupts recreational services. The parks have been an urban oasis to New Yorkers since the 1800s. It's been a haven throughout the COVID-19 pandemic. So what the NYC parks have to do is that they put these caution signs throughout the parks. Again, I just want to show Prospect Park. I am focusing on microcystis blooms, but there are also other nuisance blooms. And you can see it kind of looks like grass. So it's also dangerous for kids. They think it's just part of the grass. Okay, so now I want to link high phosphorus concentrations with microcystis blooms at Prospect Park. So in the summer of 2011, the concentrations of phosphorus into the feed of Prospect Park Lake measured 0.63 plus or minus 0.07 milligrams of phosphorus per liter. That doesn't sound like a lot, but it resulted in a loading rate of 47 milligrams of phosphorus per meter squared per day. So that value definitely surpasses what is considered healthy for the ecosystem. So this results, unfortunately, every summer, Prospect Park lakes suffer from chronic and significant microcystis blooms. And here is a photo from the Phyto app that my lab mate Nia Renee recommended that I download. So I recommend y'all to download it if you guys want to ID phytoplanktons. Okay, so the location. The study site's located in New York City. Right here is Manhattan. Brooklyn College is somewhere around here. This circle is just to note Prospect Park. In this slide, we have just a zoomed in Prospect Park in Brooklyn. This red star just indicates where our study site's located. Okay, so now I want to just walk y'all through the water course at Prospect Park. The feed starts here in the northwest corner, and it flows down in elevation through small streams and small lakes, and eventually the water course all ends up into Prospect Park Lake. There is a microcystis bloom hotspot at the Audubon Boathouse Center. This is a big issue because you can see it looks like slime green. A lot of people like to hang out here at the Boathouse and Audubon Center. Also, a lot of people like to get married here, so this is not going to look good in your wedding album. There's also microcystis bloom hotspot at Prospect Park Lake, so that's not good. Again, here's a photo of harmful algal blooms at Lake Proper. So are there any solutions? How do we remove phosphate before it enters the water course and to decrease the harmful algal blooms? So one possible solution that we're looking into is EcoWare technology, which is a modular hybrid green infrastructure. It was actually developed partially by NOAA EPP, by my research advisor, Professor Jennifer Terrier, and her colleagues here at FAMU. All right, so what is it and how does it work? So EcoWare is a confined modular green infrastructure system. It is sealed with a black liner. It has a integrated valve and pipe systems at its base. It is about 4 feet deep, gravel, sand, topsoil, and native flowers that are both water and drought tolerant. There is a valve here that can be opened and closed to activate this passive GI system. It intercepts and stores known water volumes. It controls water retention time and also soil conditions. Okay, so when the valve is closed, the water comes into the system and you can control the water table height. So it is right below the plant zone, the plant root zone, so the plants can take up the water, has access to it. And this creates a 2-layered system. So the top layer is a well-drained aerobic layer that enhances the decomposition to degrade pollutants. The bottom layer is a water saturated layer that goes anaerobic. So this allows for some important processes by bacteria to enhance nitrogen removal, and also important for my study, it decreases pH and it desorbs the phosphate in the soil particles, making the phosphate available for the plants to uptake. Also, a neat benefit from EcoWare is that you can close the valve and it creates this artificial aquifer for the plants to have access to water. Also, this helps with decreasing maintenance costs where you don't have to irrigate it. And also EcoWare can be made operational. So in the case of an oncoming storm or an environmental event, there's a smart sensor which will open the valve and release the water, so the system is prepared for an oncoming event, or as well, you can set it on a timer or you can just open it. So the goal to my research is to evaluate the potential of EcoWare installation in Prospect Park for mitigating the harmful algal blooms. Objective number 1 is to determine the phosphate removal efficiency, and objective number 2 is to access to what extent this offsets the microcystis growth and toxin production. Okay, so this is just an aerial view zoomed into the pilot sites. So right here is like Dog Beach. If anyone's familiar with Prospect Park, here's like the ballpark. So there's 2 sites. They're each roughly 600 square feet. You can kind of see the outline. Yeah, so there's the meadow, which has native flowers, and the lawn site, which is topped with grass. Here's a nice photo of the meadow. So it's a combination of water tolerant and drought tolerant flowers. And it looks pretty for everyone, and also the wildlife. Here's the lawn. I took this picture early in the morning, so the park's not that busy, but Prospect Park is a very urban park. So you have usually people here and dogs. And now I just want to go through the materials and methods. I'm going to start with the field. So first, I start by sampling field duplicates from the inflow port, and I also use a handheld YSI for environmental data. And then after 48 hours, I go back to the field and I again collect field duplicates and I use the YSI. And now I'm gonna go, so from Phosphate Park, I go to Brooklyn College. And while I transport my samples, I transport them on ice. So for the sample processing for phosphate, I use a 0.7 micron filter to filter out the particulates and the water. And then I store the filtrates in the freezer for subsequent analysis. For my phosphate analysis, when I'm ready, I use the Murphy and Riley 1962 protocol. I do my concentration standard. I run it through the spectrophotometer at wavelength 882 nanometer. Once my calibration curve is good, I do the same protocol with my samples. Here are some preliminary results from summer 2021. The y-axis shows the phosphorus milligrams per liter. X-axis shows inflow and outflow from the EcoWare samples. As you can see, the average inflow was 0.61 milligrams per liter, which is very close to what we saw in 2011. So there is a significant removal of phosphate concentration of 43%, but past large studies, we've seen really close to 100%. The installation was done at the peak of COVID, so we weren't able to overlook the construction. So plans for spring through fall 2022, myself, Professor Cherrier, and a few students at Brooklyn College, we're gonna go there, tweak the EcoWare system to try to enhance the phosphate removal. I will be monitoring for phosphate removal through the growth season. And I'm really excited about this. I'm gonna add a new piece that hasn't been done to the research. I'm going to be collecting inflows and outflows and run a time series for microcystis incubations from the growth season. And the significance, why is this study important? So if successful, Prospect Park Alliance will install EcoWare systems underneath the park's field. That's why we have the lawn study site. And also other city parks are following the study. So if it works, other city parks are looking to install EcoWare. Here are my acknowledgements. I would like to thank NOAA for this experience. Also, I wish to acknowledge Prospect Park Alliance and Brooklyn College for providing me this valuable hands-on learning opportunity. And finally, a big thanks to all the fellow EcoWare researchers here at FAMU. Questions? Sorry, here at the front.
Have you thought about running any chlorophyll or isotope analysis on output?
Definitely, but my research advisor is like always telling me to focus on one thing. I want to add satellite images. I want to add chlorophyll. So yes, that definitely. But we're focusing more on phosphate because what they do is the orthophosphate creates a film to kind of stop the lead leaching. So we're focusing mostly the priority for Prospect Park Alliance is the phosphate, but yes, I want to add as much as I can.
Thank you.
Thank you.
When you stated that the 42 milligram per day, is there like a standard that's considered like hazard that you compare it to?
That's a really good question. I'm going to have to get back to you on that one. I forget exactly what is considered healthy, but I know that it's because of the accumulation sometimes. So it's not just adding the orthophosphate. What happens is that it accumulates in the soil and it stays there. So there's just an accumulation of phosphate in the water. So it's not just the input of orthophosphate, but from the past 2 decades, there's just an accumulation of phosphate in the feed. So the loading is an issue, but also the accumulation of phosphate in the water itself already is a problem. I'll get back to you on that.
Thank you.
One quick question. You said that since there was a lot of older buildings in New York, there was lead in the water. Do the plants help in like phytoremediation of that lead in the water, or does that's what the phosphate takes care of? So where does the lead go in that process?
What do you mean by phyto? Can you explain that?
Basically using plants to remove like objects from chemicals from water. So where does the lead in the water from New York like accumulates, or does the
The
lead get dissolved?
orthophosphate creates like a film,
Uh-huh.
so it seals the lead pipes to avoid the lead leaching.
Oh, okay,
So
okay.
we're fixing
Got it.
one problem by
Yeah, got it.
creating a new.
Yeah, so the lead is not in the water anymore.
Don't quote me on that one.
Okay.
Not as much, sir.
Yeah, not a,
Yes,
Well, excellent presentation.
thank you.
Do you have an idea of the layout that PPA is suggesting for your systems throughout the parks?
What do you mean? Oh, like, so
How
there's.
would they locate the system?
Yeah, sure. So they're super excited already. We're just like nerds and we're like, no, we want more removal. But let me see if I can go back. So yeah, there's like certain spots like where you saw the blooms were, so that would be kind of ideal to install an EcoWare, but we're also, the park is interested in installing EcoWare under the grass, because if we, put a whole bunch of native flowers, that looks really good and it's great, but I don't think New Yorkers are gonna like to sit on a meadow. So we have to keep the grass and the lawn, so there's access to the public.
So maybe look at the topographic decline and just.
Yeah, so the water flows down gravity. Olmsted designed the park and also Central Park. So yes, it flows down through elevation. Yeah, my lab mate Reese LeVay, actually his master thesis was on which locations and sites would be appropriate to install more EcoWare. Right now it's just a pilot study.